Okay, here we go. So question 4. Use logarithms to solve the equation 5 to the x minus 1 equals 120. Right, so we're doing, get a pen. We're doing 5 to the x minus 1 is 120. So we're going to take logarithms of both sides. Now, it doesn't matter what base you use as your logarithm, except we're probably going to need to use the calculator at some point. And it's easier on the calculator to use log base 10, although most of you have a calculator that will allow you to choose any base in there. So in theory, you could do this with any base number, but let's do it with log base 10. So we're going to do log, that's an x, sorry, 5x minus 1 is log of 120. Now we've just written down all these laws of logarithms. One of them says that the power here comes down to the front. So this becomes x minus 1 times log 5. Equals log 120. Now remember, all we're doing at this stage is solving an equation that has some numbers in it. It only has x as an unknown. It's like having an equation that says something like, well, 3 brackets x minus 1 equals 16. Just made something up. But that would be the kind of equation, wouldn't it? We've just got a number times x minus 1 equals a number. That's all that this means. Now I think the next move with that equation might be to divide by 3 and then add 1. That would sort it out, wouldn't it? So we're going to do the same kind of thing. We are going to divide by log 5. And then add the 1 to get what x is. And there we go, and you should be able to do that and come up with an answer. Just check. I think the answer should be 3.97. Do we agree with that? That's the 3 significant figures. Okay. Now, just as we're looking at this, it's worth pointing out. As I say, most of you have quite similar calculators. Most of you have the Casio FX 83 or 85 GT Plus, or the EX, or the 991 EX Plus, or something. One of the recent Casios, and you have a button towards the top right-hand corner of your calculator that says log, and then some square blocks that are coloured in to allow you to put the base and to put the number in. So if you really wanted to, you could use that button for this. And you do have that alternative method through it. So, faced with 5 to the x minus 1 is 120, we could rewrite that, because that's ready for that logarithm form. That says log base 5 of 120 equals x minus 1. That's how we turn that into a logarithm statement, isn't it? 5 to the x minus 1 is 120. And so you could also do x is log base 5 of 120 plus 1. Make sure the plus 1 isn't in the log. And so if you try that on your calculator, you'll get the same answer. You'll get 3.97 by doing it that way. Has anybody checked that? So you've got that as an alternative. The reason it's an odd kind of thing, because those calculators are a relatively recent thing. If you go back 7 or 8 years, then there weren't any calculators where you could change the base. So you didn't have that option a few years ago. So at the time that the syllabus were written and the questions were designed, then it wasn't an option to do it that way. So you have got that shortcut if you want to use it. They intended you to do it that way. Part B, we're asked to solve this equation. It's maybe a good time just to mention that numbering convention. I think we know this already, don't we? But if a question is part 1, part 2, part 3, with the little Roman numerals, that means that they're all interconnected, that you should be using the same numbers in part 1, 2 and 3, that part 1 is influencing what happens in part 2, you know, maybe there's a hence coming in there somewhere, they're all connected. If a question is parts A and B, then that generally means that they're unconnected. They may be from the same topic area, but you're not expected to use your answers from part A and part B. They're separate questions. So noticing the part B means that our work that we've done in part A doesn't really affect what happens here. It's a completely fresh start. Before we can do anything with this, we want to get log base 2 on both sides, so we kind of bring things together. Now we need it to add them, we need the same number in front of both logs. So let's write this as, whoops. Let's write this as log base 2 of x plus log base 2, can we go straight to writing that as 9? We know it would be 9, don't we, because it's log base 2 of 3 squared. 3 squared is 9. Is log base 2 of x plus 5. Now I'm interested in getting these both the same, log base 2 of something equals log base 2 of something. So that is log base 2 of 9x, because when we add these we would multiply, equals log base 2 of x plus 5. And now we can get rid of the logarithm completely, can't we? Because we're doing the same operation to both sides, so the thing we're doing the operation to must be the same. So now we can just say 9x must equal x plus 5, 8x equals 5, and x equals 5/8. And there we go, that was quite a nice second part of the question. There we are. All happy? Great.